Hi everyone, welcome back. In this video, we will discuss top 10 microservices interview questions and answers. What are microservices and why are they used? Microservices is an architectural style where an application is built as a collection of small independent services. Each service focuses on a single business capability and can be developed, deployed, scaled, and maintained independently. Organizations use microservices because they improve agility, allow teams to work autonomously, enable faster deployments, and provide better scalability. Unlike monolithic systems, microservices minimize the impact of changes and prevent a single failure from crashing the entire application. In interviews, highlight that microservices are ideal for complex evolving systems where independent deployment, scalability, and resilience are critical. Next question: what is the difference between monolithic and microservices architectures? A monolithic application bundles all components, UI, business logic, and data access into a single deployable unit. This makes development simple but scaling and updating difficult. A single failure can impact the entire application. Microservices break the application into separate, independent components. Each service can be scaled individually based on load, deployed without affecting others, and maintained by separate teams. Microservices introduce complexity with distributed communication, service discovery, monitoring, and data management. Interviewers expect you to explain that monoliths are simpler but less flexible, while microservices offer agility at the cost of operational complexity. Next, what is service discovery and why is it needed in microservices? In microservices, services scale dynamically. Their IP addresses and ports change frequently. Hard coding service endpoints is unreliable. Service discovery solves this by allowing services to register themselves at a startup. Tools like Eureka, Consul, or Kubernetes service registry store active service instances. When a microservice needs to call another service, it queries the registry to obtain the correct address. This enables loose coupling, automatic scaling, and fault tolerance. Interviewers want you to highlight that service discovery ensures services always find each other even in dynamic cloud-native environments. Next question: what is an API gateway in microservices? An API gateway acts as the entry point for all client requests. Instead of calling individual services directly, clients call the gateway. It performs responsibilities like routing, load balancing, rate limiting, authentication, logging, and response aggregation. Tools include Spring Cloud Gateway, Kong, Apigee, and NGINX. API gateways reduce client complexity and provide centralized cross-cutting logic. They also hide internal service URLs, improving security. Interviewers expect you to mention that gateways improve performance, standardize communication, and simplify interaction between clients and service clusters. Next, how do microservices communicate with each other? Microservices communicate in two ways: synchronous and asynchronous. Synchronous communication uses a REST API or gRPC. It is simple but can create tight coupling because client services must wait for responses. Asynchronous communication uses message brokers like Kafka, RabbitMQ, or ActiveMQ. This reduces coupling because services publish messages without waiting. Event-driven architectures rely on this model for scalability and resilience. Interviewers want the clear explanation that choosing the right communication pattern depends on use cases, latency requirements, and service independence. Next question: what is circuit breaker in microservices? Why is it important? Circuit breaker is a resilience pattern that prevents a failing service from overwhelming the entire system. If service A calls service B and B becomes slow or unresponsive, the circuit breaker detects repeated failures and opens the circuit. This stops further calls to B and returns a fallback response immediately. Once B recovers, the circuit breaker closes the circuit and resumes normal communication. Tools like Resilience 4, J and Hystrix implement this pattern. Interviewers expect you to mention that circuit breakers prevent cascading failures and keep the system stable. Next, how do you handle centralized configuration in microservices? Maintaining configuration inside each microservice becomes complex as the number of services grows. Spring Cloud Config Server solves this by storing configuration in a central Git repository or file system. Each microservice retrieves its configuration at startup. With the refresh mechanism, services can update configuration without restarting. In distributed systems, centralized configuration ensures consistency, version control, and easy updates across environments. Interviewers want you to highlight that centralized configuration reduces duplication and improves maintainability. Next, how do microservices handle data consistency? Unlike monoliths, microservices maintain their own databases to remain loosely coupled, but this creates challenges in managing data consistency. Strong consistency is often impractical, so microservices use eventual consistency patterns such as Saga, Outbox, and event sourcing. Saga coordinates transactions across services using either choreography events or orchestration as central controller. Interviewers expect you to explain that microservices avoid shared databases and use asynchronous patterns to maintain integrity across distributed systems. Next, how do you monitor microservices effectively? Monitoring microservices requires collecting logs, metrics, and traces from multiple services. Tools like Prometheus, Grafana, ELK Stack, Zipkin, Jaeger, and Spring Boot Actuator help achieve this. Logs capture events, metrics track performance, and distributed tracing shows request flow across services. Interviewers want you to mention that proper observability is mandatory for debugging failures, analyzing performance bottlenecks, and ensuring system health. Next, what are the key advantages and challenges of microservices? Advantages include independent deployment, faster development, better scalability, fault isolation, flexibility in technology stack, and easier team ownership. Challenges include distributed complexity, network latency, testing difficulty, data consistency, monitoring overhead, and DevOps requirements. A good microservices architecture balances these benefits and challenges through automation, observability, resilience patterns, and cloud tooling. Interviewers expect you to show understanding that microservices provide agility but come with significant operational responsibility. That's it. These are the frequently asked interview questions on microservices in the interviews.